Today we're going to be multiplying polynomials. And just as a little short review, I'm going to start with a monomial times a monomial. Now remember, polynomial means many terms. You can tell how many terms it has by looking for plus or minus signs. So a monomial times a monomial, for example, would be 2x squared y times 3xy. So 2x squared y is a monomial, 3xy is a monomial. Notice there's no plus or minus sign separating anything. So this means they each have one term. So in this case, we just multiply the numerical parts. 2 times 3 is 6. And remember, when the bases are the same, you add the exponent. So we use those exponent rules. So x squared times x is x cubed. And y times y is y squared. Now, notice that remember that when we are multiplying here, we did not have to have like terms to multiply. With adding and subtracting, we had to have like terms. Well, now let's try a monomial times a binomial. A binomial has two terms. So it might look something like this. 3x times 2x plus 5. I don't know why it's doing those extra little dots there. A little annoying. Okay, and when you have a problem like this, we're just going to distribute. So if you remember, when you're multiplying by a monomial, you just need to remember to distribute. So we'll multiply 3x times 2x. We get 6x squared. Plus, because this sign right here is plus, we multiply 3x times 5, and we get 15x. And that would be our answer when we multiply the monomial times a binomial. Let's try a monomial times a trinomial. So if I had something like 2x squared times 3x squared plus 2x minus 5. Okay, again, since I'm multiplying by a monomial, and this is a trinomial, notice it has three terms, 3x squared, 2x, and 5. Those are the three terms. So I'm just going to distribute. I get 6x to the 4th power. Then I'm going to multiply 2x squared times 2x, it's a plus sign in between, and I get 4x cubed. And then it's a minus sign next, and 2x squared times 5 gives me 10x squared. And that's my answer. Now, I do want to point something out that came up in class a couple days ago. If the problem that I just wrote down is different than the problem that I just did. When I was multiplying a monomial times a trinomial, I distribute. And when you distribute, it's because I had a plus sign here, a minus sign here. I had three terms, and I was distributing the 2x squared to each term. That's different than the problem I have here, which is these are all three monomials. So if I were multiplying this example, I would just multiply 2 times 3 times negative 2, which would give me 2 times 3 is 6, times negative 2 is negative 12. Then I would do the exponent rules. So we would have x times x squared times x gives me x to the 4th. And y times y squared gives me y to the 4th. So in this case, I do not distribute. Okay, so watch out for that. Don't confuse that when you're multiplying a monomial times a binomial or a trinomial. before I give you an example with algebra, with variables for a binomial times a binomial, I want you to think to something like 23 times 35 and how you would do that. So if we were going to multiply this, we'd write it out something like this. And we would start with 5 times 3 is 15. Now I'm doing it a little differently. I'm not going to carry the 1 because I'm going to think about what's next. Now I don't really do 5 times 2. That's not really a 2. It's really a 20. So I'm going to multiply 5 times 20 and I get 100. And then I don't really multiply 3 times 3 because really this 3 is in the tens place, so that's really a 30. So I'm multiplying 30 times 3 and I get 90. And then last of all, I'm multiplying a 30 times a 20. And when you multiply 30 times 20, you get 600. And if I add those all together, I get 805. And that's the answer when you multiply this out. Now we have little shortcuts when we do that, but that's the idea. So I want you to think about this as 20 plus 3 times 30 plus 5. So really, it's a binomial, 2 terms, times a binomial. And I'm going to have you look at it this way, just as a way to organize with these 4 steps here. If we were to write out 20 plus 3, then make a little chart like a times table. And we're going to have 30 plus 5. 20 times 30 is 600. 3 times 30 is 90. 20 times 5 is 100. 3 times 5 is 15. And if you added up those parts, you get 805, and that was the answer. So we're going to use that idea to help us multiply binomials. So now let's think about this binomial times a binomial, 2x plus 3 times 3x plus 5. So I'm going to make a chart, and I'm going to need 4 spots for my chart. So I'm going to have 2x plus 3 and 3x plus 5. So when I multiply 2x times 3x, I get 6x squared. Because remember, 2x is a monomial when you look at just that part of it, times 3x. So 2 times 3 is 6, and the exponent rule tells us bases are the same, so you add the exponents and we get x squared. In this box, I'm going to multiply 3 times 3x, so I get 9x. In the next spot, 2x times 5 is 10x. And in the last, 3 times 5 is 15. So then I'm going to add these parts together just like I did in the numerical example, and I get 6x squared plus 9x plus 10x was 19x, because I'm going to add like terms, plus 15. And that's my answer. Now if I'm multiplying a binomial times a trinomial, I'm still going to use that idea of putting it in a box. I just need a bigger box because I have a binomial, I have 2 terms here, times a trinomial. So I'm going to need, instead of 4 spots, I'm going to need a total of 6 spots. So I'm going to divide this one in half this way, and this one into thirds. So I have 2x squared minus 3x plus 1. And here I'm going to have 3x plus 5. Now I could have made my box going the other direction and put the 3x plus 5 across here, and a 2x squared minus 3x plus 1. I could have done that vertically. It wouldn't make a difference. So now I'm just going to fill in each spot. So 2 times 3 is 6, and x squared times x is x cubed. 3x times negative 3x, I multiply 3 times negative 3, I get negative 9. And x times x is x squared. 1 times 3x is 3x. 2x squared times 5. 2 times 5 is 10, and then I'm just going to have an x squared. 5 times negative 3 is negative 15, and then I'll have a negative 15x. And the last spot, 1 times 5 is 5. Then I have to find the like terms. Now, you'll notice when you're looking for those like terms that you'll find that they're always on the diagonal. So the x squareds are here. If there are like terms, you'll find them lined up that way. So we can combine those. So I'm going to have a 6x cubed. I have a 10x squared minus a 9x squared. So 10 minus 9 is 1. So I have 1x squared, or I could just say x squared. You can put the 1 there if you want. Then I have a negative 15x plus a 3x. Well, negative 15 plus 3 is negative 12, so that gives me negative 12x. And then the 5, there's nothing to combine with, so it's just plus 5. And that's my answer. And if you need to go over any of these parts, you can rewind this and take a look, and we will practice these in class tomorrow.